All right, we got another short one for you. This one's on polarization. So light can be polarized. What does polarized mean? It just means it's in one axis. So it can be polarized either with film or through reflection. And since light can only be linearly polarized, that means only transverse waves are the ones that can be polarized. So you can't polarize sound, but you can polarize light. And film, the way it polarizes light is through absorption. So you can think of polarization as like a picket fence. If you imagine picket fences, they're sticking straight up and down. Light comes in and before light gets polarized, it's moving in all directions. Remember, light is an electromagnetic wave, so it's electric and magnetism moving in opposite directions, perpendicular directions to each other. And then, and it can be tilted at any angle. Now, only the light that is going up and down in parallel to these pickets will be able to make it through the fence. Anything that's turned sideways is going to get blocked off. So here I have one going up and down, and here I have one coming in and out of the board, as well as I can draw it. The one that's going into and out of the board is going to get hit by this and stopped, whereas the one that's going up and down is going to go straight through it. So you can think of it in that way. Now here I have a couple pieces of polarized film. As you can see through both of them, and that's because light of one pole is being able to go through it. But now watch this. I put them in front of each other. Look, you can still see it. But as I rotate it, how does that happen? Clear, dark. It almost destroys your brain. Now imagine I have one picket fence straight up and down and one turned sideways. Well, only the straight up and down waves are going to go through it. Then when it gets to the next fence, they'd have to be going sideways to go through it. So there's no light left over, which is why you can't really see anything through this. I rotate it. Now you just have a longer section where it's only blocking out the straight up and down waves. Similar things can happen, and this is how like sunglasses work. It takes out all of the light that's not in polarization with it. It's not lined up with its axis. So here you see we have the strength of light. It's equal in all directions. After it passes through the glasses, only one direction remains big. Over here, we have light coming down and it hits water. Reflecting off of the surface of the water can cause it to polarize. Now, if that water then reflects and goes back up through the glasses, then it's going to be almost nothing, which is why they tell you to use sunglasses when you're driving on roads and stuff, because it can reflect off the surface. That light becomes polarized and it's not in the same direction as your glasses, which is why it reduces glare. An interesting thing can happen with sunglasses, though, if you're wearing them and the sunlight angle is perfect. What it can do is stop entirely all of the reflection coming off of the surface, meaning you can see only the light that's coming off of the bottom of the water. So it almost makes the water look like it's completely transparent. You can see down to the bottom of lakes as long as enough light is coming up from it. But that's all we've got on polarization. Let's just look at it one more time because it's pretty cool. Let's get it on a white section. Boop, boop. Wow. If you guys want to try it out in class, let me know.